What's up guys, this is Professor Spawn. In this tutorial we are going to find a derivative of y is equals to log x using, so what we are going to do is we are going to find dy by dx, right, using first principle, right? So this is also one of the standard function, and it is one of the most important function, which we call it as log x. And we know that by a first principle, what is dy by dx? So by first principle, dy by dx is limit of h tends to 0 f of x plus h minus f of x upon h. Remember that here we are using h. You can use a, you can use b, but you should also keep that in mind that here you also need to change as a or b. But here we are going to use as h. So by this formula, we are going to calculate, you know, the derivative of this function, which is given by log x. So if I apply a limit log of x plus h minus log of x upon h, right? Okay, now we have come to a point where, you know, if you apply a limit, remember this h is still there, and this will make this whole equation as indeterminate or undefined, right? Anything divided by 0 is not allowed in maths. Rather, not allowed, but the result is indefinite, right? It's not defined in maths. So you need to have some background here. So I'm going to draw some square here, and you know that log of m minus log n is log of m upon n, right? So as here we have a subtraction, so if you have a subtraction of two terms here, so log m minus log n is equals to, this is given by log of m divided by n. In our case, m is x plus h and n is x. So I can pretty much use this formula, and I'm going to substitute here. So limit of h tends to 0, right? Here I can use it log of x plus h divided by x upon h, right? And I can simplify it as limit of h tends to 0 log of, so if you divide this x with each term, you'll get as 1 plus h upon h, right? So this is what you have after simplification. So you used log of m minus log n, which is log of m upon n, and then we actually divided this denominator with each term of the numerator, and then you have this. Even if you apply a limit right now, it will still result in undefined. But hey, I know that limit of h tends to 0, limit of h tends to 0, log of 1 plus h upon h is equals to 1. This is by formula. It says that limit of h tends to 0, whatever variable you have here or whatever constant you have here, log of 1 plus h upon h is equals to 1. Remember that this h and this h is same. Can I do something here that this h here, in our case h is h upon x, if somehow I can have h upon x here, this whole, if I apply a limit, then this whole will be equal to 1. I can pretty much do that. How? I can multiply x here and divide x here, right? Eventually this will cancel and give me the result as h. So I can do that, right? So I'm going to do that here. So what I'm doing is, at the denominator, I'm actually multiplying x and dividing x. Now this h upon x and this h upon x is same. And so what I'm going to do is, I'm going to keep this x out of this limit. So 1 upon x limit of h tends to 0 log of 1 plus h upon x upon h upon x. And now if you apply a limit to this, right, to this, This is pretty much, this is same as what this is similar to this, and we know that the limit of this is 1. So the answer is 1 upon x. So dy by dx is equals to 1 upon x. This is the derivative of the logarithm of x, right? This is also important that you need to keep this in mind. Keep in mind, right? So the derivative of a log x is 1 upon x. So this is it for this lecture. In the next tutorial, I'm going to teach you, we are going to see about, the standard derivation of some function. I'm going to rather draw a table and we are going to see the standard function, because I'm going to stop here for the finding the derivative of a standard function using first principle. And in the next tutorial, we are going to see the rest of the standard function and the direct formula of those derivatives, right? And you can, uh, get those standard functions, which is unsolved and solid on paper. And if you have doubt, you can reach out to me. I will be happy to help you. So in the next tutorial, I'm going to show you the rest of the function with their formulas, and then we are going to start solving the derivative of the function. So till then, goodbye and see you.